this video, we are going to talk about some of the key concepts of AWS CDK, and then I'm going to compare AWS CloudFormation with AWS CDK. So let's dive in. So let's understand the basics first. What is AWS CDK? If you don't know, AWS CDK is very similar to how SDK or software development frameworks looks like. So in the traditional sense, when you are using SDK, you will be connecting to your third-party provider, and it makes it easy to use that code when you're writing that code. Similarly, AWS CDK allows you to write code to create infrastructure in the AWS. So in terms of definition, it's like an open source framework for modeling cloud infrastructure. Now let's understand the attributes for AWS CDK. The first, the multi-language support. Second, CDK is open source. What that means, you can contribute to the project. If you think that CDK is missing any feature, you can go to the GitHub repository and then you can find a way, either fix the bug or you can contribute and launch new features. If you think that some of the resources are not supported, you can go and add that kind of the feature that you're looking for. Three, it's a cross-platform. What that means, the CDK version can be deployed or used in any of the platform like Windows, Linux, or Mac OS. So you don't have to struggle that, okay, this Windows is not supported or Linux is not supported. Whatever operating system that you're using, CDK is supported for all three of them here. Now let's move on to why should we use AWS CDK? Because, there are many alternatives available. So why should we care for AWS CDK? And what is the point of using AWS CDK? So to answer this question, we have to understand how we're building our cloud applications. So first, let's understand the complexity first. In modern cloud applications, they're comprised of multiple building blocks like Lambda functions, API gateway, event bridge, and then different queuing services, streaming services, database services. It's really complex. So in a typical application, you will have 5 to 10 or even like 30 plus resources if you're building really complex applications. So that kind of complexity makes it really difficult to create that kind of the resources in the cloud. To facilitate this, AWS provide multiple options, such as using AWS Console. So why shouldn't we use AWS Console? Well, in AWS Console, first, this is how it looks like, right? So you have to define all these properties. Even when you're creating a simple VPC, you will have to provide all these configurations and the resources that you're using, or how and where you should be launching. So there are different options of creating any configurations. And because of these different choices, it gets really complicated. And even though if you don't mind using this, you can use this, but let's understand the downside of using AWS Console for creating your resources. So first, it's manual, time consuming, and then you will be spending a lot of time doing the configurations. And because this is only available in the console, you will not have any version control. You will not be able to reproduce the same infrastructure in the, let's say you created one in dev environment, you will struggle to replicate the same in the production environment or in the staging environment. So you are missing the core benefit. What that core benefit comes from, and this comes from using DevOps principle, 3 principles that most of us are already using: repeatable, reliable, and auditable patterns. So if you are not able to take advantage of the DevOps, that means you should avoid building any production application using AWS Console. So what are the alternatives now? That's where there comes the need for using infrastructure as code. So infrastructure as code, what that means, these resources that you're creating, now you can create these resources in the cloud, like whether you need to create a new server, new database, you can just write the code in your IDE, whichever IDE you are using, and that when you deploy this code, it will automatically provision the resources that you're going to need to run that application in the cloud. Now for this, there are multiple options for this infrastructure as code services, but let's understand why do we use infrastructure as code. So first, it's a single source of truth to deploy the whole stack, which was not possible with the console. So with console, you would have to deploy and do the manual. You have to repeat the steps manually in each environment. With this, you can create the stack, have the configuration for production, dev, and stage, all 3 environments, or if you have multiple, you can do so. Second, you can replicate, redeploy, and repurpose the same stack because it's a code. So all these attributes that you have in the code will apply to this as well. And versioning, because you will be checking in your code in the GitHub repository or any other version control that you're using. So with that, it allows you to have versioning of your infrastructure. So you can all see what is changing and what caused the problem in your environment if you deploy anything, and you can go back to the previous versions as well. And the last one, you can do your CI/CD pipeline. So this is where the DevOps part I was talking about comes into play. So you can take advantage of CI/CD pipelines and deploy the code to AWS, and if it fails, you can roll back. So this is how it looks like. So you create a template, and in the template, you can have multiple stacks, and then you can deploy that to AWS. So with the CI/CD pipelines, you can configure something like this. You create in dev environment, you test it, deploy in the staging environment, and after successfully deploy in production, you can run the demos. And if demo was successful, you can deploy to other regions. Now, there are multiple options that you can use, but today we are only going to focus only on two: AWS CloudFormation versus AWS CDK. We are only choosing these two, but there can be others. So let's understand how AWS CloudFormation works. So in the AWS CloudFormation, you write your template, a CloudFormation template. That code can be in YAML format or in JSON format. You can use any sample templates, or you can create your own templates. There are multiple alternatives. From this template, you deploy this template, either uploading directly to CloudFormation, or you can upload that to the S3 bucket, and from there you can deploy. Now, CloudFormation, it's a service from AWS. What the service does, based on the template, it creates all these resources in AWS CloudFormation. Using that API, creates these resources and provision these resources for you in AWS. Now these resources becomes the building blocks for the stack. So in one stack, you can have more than one resource. And this is where the stack definition comes in. And now that stack is used to run your application in the environment. Now that stack can be one stack for the dev environment, production environment, and a staging environment. So this is how the CloudFormation works. So in CloudFormation, we don't really have any obvious problems. Basically, this allows you to deploy your infrastructure as code. You can author it with any code editor, check it into a version control system, and review the files with team members before deploying in the production. So this seems perfect, right? The transactional nature of CloudFormation is just, many ways where you can either run this transaction. Transaction means if you're deploying the code, if this is successful, good. Otherwise, you can roll back to the last good state. So that's like, is it compliant sort of a transaction that comes with the CloudFormation? That's great, right? And that is one of the reasons it's really popular. On top of that, CloudFormation is declarative infrastructure as a code service. What that means, you can define the state of your solutions via template, and which you can deploy either command line or console or through the APIs that is provided. And I think there is only one problem with CloudFormation. You have to write that template, and that template can get really complicated because when you're deploying multiple services and multiple environments that you're deploying, so you end up creating very long list of configurations that can be like several hundred lines of configurations to several thousand lines of configurations based on the type of the application that you're deploying. And that is the biggest problem that I have seen, where, either when you're doing the code check-in and check-outs and things like that in the review process, you will be looking for the changes that you're deploying in the CloudFormation. Problem is, in the resource template, you're only deploying the resources. So you can take a look at the permissions and how that will be used. But we often end up providing more permissions than needed. That is one of the problem. And then the configurations, you have to remember all these configurations for the CloudFormation, which can get much, because there's hundreds of different properties that you have to remember, and that is a bit confusing when you're deploying this, and kind of reduces the reusability side of it, because everything that you're writing is limited to either YAML or the JSON file, and that's where the problems comes in. And this is the problem that we are solving with CDK. You add CDK in front of this pipeline that I explained before. So you are adding a CDK. What CDK does, you can write the source code in your version control system in your own programming language instead of writing that in the YAML and the JSON file. CDK will act as a compiler and take this code, compile this and create the template by synthesizing this source code into a CloudFormation template for you. So you don't have to remember the different configurations and the properties, and you can avoid that creating one file for the stack in your code repository. Now you can think about when you need the resource in your code, that's where you will make a request for creating a resource for that application. And with that, first, you're writing code in your own programming language. Second, you can create different modules and reuse that piece of infrastructure if needed elsewhere. So you know that, okay, this unit was tested and this kind of the resource is perfect for that kind of the application, and you can deploy this. And that's where the speed comes in. You don't have to write thousands of lines of configuration. You just have to write what you need, and it will automatically create that template for you. So let's take a look at an example for this. Now, this example is for creating a containerized app deployed in AWS Fargate service. On the left-hand side, you can take a look at it that we are creating a VPC. In that VPC, we are only passing the name of the VPC, then we are passing the max availability zone 3, then we're creating a cluster in that VPC. And then we're also providing the configuration for the Fargate service, like, okay, the CPU size will be this, and desired count is this, and memory limit, and so on and so forth. And then also the registry image. With this, it will create that containerized app for you. So just to compare, if you were doing that in YAML or in CloudFormation, you would have to write 500 plus lines of code for this deployment only, which you can only do with these like 6-7 lines of code here on the left that you're seeing. And this will provision 50 plus resources for you when you will be deploying this into your account. And as you can see, the language is C# here, right? So this is one of the language that you can use, but it's not limited to just C#. So let's take a look at another example. So in this example, I'm only using, just to show you that you can use multiple languages to support your use cases. And in this, we're creating a sample application to use SQS along with SNS topic to subscribe. So it's a very simple 3 lines of code that you're writing. First, you're importing the CDK, and then construct, and then using them to create these resources. So this will create these resources for you. Like this 3 lines creates 3 resources. And in CloudFormation, this would have been more. So that's where this allows you to reduce the complexity of your deployment and the code that you're writing, and this kinds of speed up the overall deployments, like the CDK structure, how everything works. So from the top, you have an app, that's the root construct, and the root construct can have multiple stacks. So you can have multiple stacks. That can be stack 1 for the dev environment, stack 2 for the production environment, or you can even test within the same environment with multiple stacks. So you can have multiple choices based on the business logic. You can create multiple stacks. Every stack can have 1 or more construct. So construct is like, think of it like a smallest unit in the CDK. So the smallest one, you can create S3 bucket or a Lambda function, or you can go a higher level. We will talk about these different levels, what that means. So construct is basically a representation of AWS resources like Lambda, S3, or any combination of these resources that is provided. And then a stack is basically a minimum deployable unit that you can deploy within a region and account information. And the root and the app is to kind of encapsulate everything. So we talked about CDK Construct Sites, what that is basically. So I was talking about different levels. So AWS kinds of define this in 3 different levels. L1, one-to-one mapping to your CloudFormation resources. This means your S3 bucket can become L1 CloudFormation construct, or your Lambda function will become as a L1 construct, or any other service like a native service that you have for like if you're trying to provision an EC2, that will become as your L1 construct. L2 becomes as a service level construct. So what that means, if you have a more dedicated service, let's say you want to get a value from a DynamoDB, you can create that L2 construct where this will provision a DynamoDB S3 bucket and a Lambda function. So this is kind of a library that provides you more common patterns that you can deploy using that construct. L3, this is your own construct that you're building to solve a business problem. Now this L3 can be from your internal coding repository that you're maintaining for the construct, or you can have a third party or open source construct as well that you can use. So let's take a look at the example for L1 construct. So L1, I was talking about S3 bucket. This is one line of code that says, okay, CloudFormation bucket, and you're passing the bucket name. And from there, it will create this S3 bucket for you. You can see that the type is there and the name of the bucket is there. That is generated from CDK synthesis is short for this. Is one of the command that allows you to generate and see the resources in CloudFormation. Now let's take a look at the another example, L2 example. In this one, we're trying to create a VPC. So in a VPC, it will have multiple resources. So this one line of code creates that VPC in a given region and multiple availability zone. There it will create the internet gateway for you, a public subnet and a private subnet, and divide these IPs available in one VPC into 4 subnets. And if you have 3 AZs in a region, it will create in 3 AZs. You can change this default values. So the first line that I'm showing it just with the default values, but it can be changed to generate this. So this is where you will be seeing that power, that you don't have to write that descriptive configurations properties in the YAML file for the CloudFormation. You can just write this line in your code and you're good to go to see the values. About L3 examples, so in the Construct Hub, this is where you can find many examples for Construct from AWS and multiple third parties that you can take a look at here and learn from this and use it in your coding language and in your own project. Now let's understand key features of AWS CDK. So I was talking about the construct. So construct is the one that makes it really powerful, and it allows you to build your application really fast. It cut down the amount of time you will be taking to build a new project. With construct, you can increase the reusability. And second is abstraction. So with abstraction, what it does, it allows you to object-oriented programming concepts like you can create your modules, or you can take advantage of inheritance. And these are the kind of benefits that you will be getting from the abstraction. So it kind of abstract the underlying implementation in the form of CloudFormation, and you're thinking about the high level code that is needed to deploy that infrastructure for you. 3, you can organize your project into modules like your code. Like in your code, you create different application services, and then you can define that stack that is needed to run that particular service that you're deploying, or that piece of the application that you're building. Based on whichever pattern that you're using, you can easily bring the code along with your infrastructure as code. And the 4th, you can take advantage of your existing testing framework like PyTest and whatever you are using for testing. You can bring them in, use them to run a test to make sure that your resources are actually created in the AWS, and then you can make sure that your tests are successfully passed for the resources along with your code as well. Now let's understand how you can learn about it. First, I will be building another video about how to use AWS CDK. First, a very simple basic workshop that I will be posting shortly. You can see in the suggested video here. And second, you can learn from these resources. Either go for the official documentation, you can go to the GitHub I was talking about. It's open source. You can see the implementation for AWS CDK as well. And the third, if you want to run your own workshop, you can go to the CDK workshops, and from that you can run your own workshop as well. Thank you so much. And if you liked my video and if you think I'm adding any value to you, so please do like and subscribe to this video, so that way I can use this as a feedback and start improving and providing you more value there.